Okay, so today is an extension of what we learned about work. We're learning about power. So the question is, well, what is power? Well, power is the rate at which work is done. So our equation for power is equal to work times time, work over time. Well, we also know that work is equivalent to force times distance. So we can plug in force times distance for work here, and we can derive another equation for power. Well, we know force times distance over time. We know distance over time is equal to the velocity of something. So in this case, it's going to be the average velocity that was completed over that time period. We can't state the initial and the final velocity. We can only take the average for this case. So for our units, we can see that, well, work is in joules and time is in seconds. So joules over seconds, we're going to rename this as a new unit, a watt. Not a what, but a watt, capital W. For our second equation, force times average velocity, we have newtons times meters per second. So, and actually I made a mistake here. It's going to be Newton meter per second, so not Newton over meter per second, but Newton meter over seconds is also equivalent to a watt. Okay, one thing you should know is that it is possible to do the same amount of work, although have different power outputs if the time was different. So to be putting in 100 watts of power, that'd be your output power, but doing a different amount of work if you have different time. You can see that if you change these two, it's going to alternate the power as well. Okay, for our first example, and if you need to pause the video to write down the question first, please do. So Rob and Pete move a sofa 3 meters across the floor by applying a combined force of 200 newtons horizontally. If it takes them 6 seconds to move the sofa, what amount of power did they supply? Well, first thing we want to do is write our givens. So our force is 200 newtons. Our distance is 3 meters. And the time applied is 6 seconds. Our unknown is power. So let's go ahead and write our equation. We know that power is equal to work over time, which is equivalent to, we know work is equal to FD cosine theta. In this case, our cosine theta is going to drop out to equal 1, so we're just going to have FD over T. So that gives us 200 newtons times 3 meters divided by 6 seconds. So our power output is equivalent to, go ahead and plug that in your calculator, you should get 100 watts. Okay, let's do another one. So this is a branch off the first problem. So now we have a third guy, Kevin. Kevin pushes the same sofa with an applied force of 200 newtons over a 3-meter distance. Except Kevin applies this force for a 12-second time period. So he's applying the same exact force for the same exact distance over a longer time period, twice as long. So you can already kind of predict what's going to happen to this equation. Well, now we're going to have 200 times 3 divided by a larger number. So that's going to decrease our power. If you have a larger number in the denominator, that makes our overall answer on this side of the equation smaller. Okay, so let's go ahead and find the power. Same force, same distance, now we have a different time. So our same equation, power is equivalent to work over time. We know that work is equal to force times distance over time. So when you multiply and divide that 12, you should get 50 watts. So you notice that it's a longer time period. It's going to be a different power output. Same amount of work. So just like I said earlier, that it is possible to do the same amount of work, although have different power outputs if the time was different. Okay. Let's do a little bit more complex of a problem. So here's number 3. we're going to be comparing this time. We'll be comparing motor A to motor B. So motor A lifts a 5,000 Newton steel crossbar upward at a constant 2 meters per second. Motor B lifts a 4,000 Newton steel support upward at a constant 3 meters per second. Which motor is supplying more power? So this is the weight of the object, and we know that our free body diagram looks something like this for both scenarios. So weight, and in order to lift it up we have to apply some normal force, and it's traveling at a constant speed, which means acceleration must be 0. Which means that our applied force upward, F normal, is equivalent to our force due to gravity. So we can call this F normal, or we actually, a better name should be F applied. So we're going to have two different scenarios, motor A and motor B. So this time we're given the average velocity, which was constant for both of them. So we're not going to have the equation power equals work over time, but we're actually going to use the one that we derived, force times distance over time. Knowing distance over time is equal to average velocity, we get power is equal to force times velocity. This is going to be the important equation for us this time. So power is equal to our force, which was 5,000 newtons, and our average velocity was 2 meters per second. Multiply those two together, and you get 1,000 watts. Oh shoot, I missed a 0 here. So this is 5,000 newtons, and then we get 10,000 watts. Okay, let's do motor B. So motor B, same equation, force times average velocity. Our force this time is 4,000 newtons, steel support, and our velocity is 3 meters per second. Multiply those together and you should get 12,000 watts. So, well, if you looked at the answers, which one supplies more power? Motor B. Okay, let's do one more example, and I think you guys should be okay with power. Okay, so in this scenario we have two different aliens. We have alien A, who lifts a 500 Newton kid from the floor to 0.4 meters in 2 seconds. So let's just draw a little scenario for us. Alien A, he's lifting a 500 Newton kid from the floor to 0.4 meters. So and then alien B is lifting a 400 Newton kid, so not as heavy as the first kid. We'll draw him a little bit smaller. And we're lifting him a higher distance, so 0.5 meters. And the time it takes for this one is 1 second, and the time it takes for alien A is 2 seconds. So we want to compare alien B to alien A, the amount of work and the amount of power. So ultimately we need to find the amount of power and work for both of them. So let's do alien A first. We know that power is equivalent to work over time, which is equal to force times distance over time. So we could find our power output, which is 500 newtons, times our distance, which was 0.4 meters, over a 2-second time period, which gives us a power output of 100 watts. And the work is equal to force times distance, so 500 times 0.4, which gives us 200 joules. So this way we can compare the work and power at the same exact time. So now let's do alien B. Let's find his power first, work over time, which equals force times distance over time. So his force was 400 newtons, because that's how much the kid weighed. Distance of 0.5 meters and a time period of 1 second gives us a power output of 200 watts. So alien B's power output is more already. We can see that. So we're going to narrow our choices down to A or D. And when we find the work done, work is just force times distance, so 400 times 0.5, we get 200 joules. So they do the same amount of work. So we can rule out D. Our answer choice is therefore A. They do the same work, but A develops more power. Or B develops more power, 200 watts instead of 100 watts.